NaOH. Production of NaOH. Sodium hydroxide is a very common caustic soda. It's a white powder, very strong base, very soluble in water. In water, completely separate as ion, called ionized. Na become a positive ion, OH become a negative ion. And if you live in the air, they will absorb moisture in the air. NaOH is one of a very widely used chemical. At home, household use, they used to make soap, use detergent, or say if your mom have a blockage pipe, you can use it to drain the blockage, or as an oven cleaner. Mineral extraction. You can use sodium hydroxide to dissolve aluminium. That's where they do the bauxite mining extraction. Now let's talk electrolysis of the molten NaCl. Now this is only have the NaCl with no other substance. This electrolysis of this melted NaCl. When NaCl, be careful, this molten NaCl is not you putting water to melt NaCl dissolved in water. Nothing like that. But rather is a piece of solid salt. Salt is a solid. But when you put to 800 degree to 1000 degree, they will melt into liquid. So that's what I mean by molten NaCl. And they will produce, through electrolysis, you can make it into sodium metal and chlorine gas. This process is done by the Dan cell, please know the name. And that is to deal with the molten NaCl. Look, this is the melted salt. No water involved. You're not putting water. The process. Let's focus on to the blue part. You have two rods, anode and a cathode. And the chloride, negative ion, will attract to the positive rod. Sodium, positive ion, will attract to the negative rod. If you look onto the equation, as you remember, from anode flow up to cathode as an electrolytic cell and require power from outside source. So anode from chloride become chlorine gas. And here's the equation. How about cathode? Sodium become pure sodium. Let's focus on anode. Anode, you from chloride become chlorine gas. That's why the gas bubbling, you're using a fume hook to collect the gas out. Sodium ion become pure sodium solid. This is a light metal. They flow onto the top and can drain out. So this is this molten salt done by Dan cell. Now look onto another one, which is electrolysis of a NaCl aqueous solution. You have water involved. And this is a competition between ion. And this process is called the charcoal alkaline process. It's the NaCl with water to react. And the product is different. This time, the product is NaOH, chlorine gas, and hydrogen gas. So these three are very useful material. NaOH, we've been mentioned, very common use. Chlorine gas also very useful. They used to make bleach, to water treatment, to make HCl, hydrochloric acid, or PVC plastic. A lot of use. Hydrogen gas. For example, to make ammonia, you need pure hydrogen gas. So I'm going to talk this charcoal alkaline process in three aspects: diaphragm process, membrane process, and the mercury process. Remember, NaCl can be in dilute and concentrate form. And if you look onto the standard reduction potential, please remember, if it is a dilute NaCl, you're going to anode, you're going to produce from water to form oxygen gas. Cathode, the upper one, will water form hydrogen gas. Please remember. How about concentrate? Concentrate, anode, the bottom one, you will have chlorine gas rather than oxygen. The top one, cathode, remain the same, form hydrogen gas. And of these three processes, all are going to use concentrate NaCl. So these two is the main formula I will be focused. The concentrate, anode form chloride, concentrate, cathode from hydrogen gas. Now let's start. The first is the albedo diaphragm. They line this mesh to separate the NaCl solely through this albedo. See how this diaphragm works. You have two compartments. One compartment, I put it green. This green compartment have the anode rod. And the blue compartment, you have the cathode rod. And they separate by this albedo diaphragm. So it's been separated into two compartments. Now let's see how it works. First, you put the concentrate NaCl, this brine in. So now they are in the first chamber, NaCl. And it will react to the first chamber anode rod. And what should it form? Look onto the standard reduction potential. On concentrate anode, it should form chlorine gas. So chlorine gas is formed. Then, now once the chlorine gas formed, the remaining is the Na. And the Na positive ion will seep through this diaphragm. When they seep through this diaphragm, it will pass on to the second chamber. And when they are in the second chamber, now the second chamber reaction. The second chamber is you're going to put water. You're going to put water into the second chamber. So, what will be the reaction? Cathode. So what happened? Water react with cathode. What should it form? The water will form hydrogen gas, as on the top of the standard reduction potential. Water form hydrogen gas and remaining NaOH. And what still remain in the solution after this hydrogen gas form? Na and OH in solution. Then you drain it out dry it out, that is NaOH. That's how you make. There is a disadvantage of this diaphragm process. As asbestos causes cancer, so this is not fair. They have a health issue. Secondly, NaOH it always be contaminated by NaCl, because when this Na seeps through, tiny bit of Cl also accidentally seeps through. So it will be contaminated. So you have to separate it out again before you can sell it. So you will add the cost. Now I'm going to talk membrane process. Membrane process is a better process and more current process. They're using the water impermeable membranes. This is a synthetic polymer called Teflon. See how it works. You also have the same chamber, the green chamber, which have the anode, and the blue chamber, which you have the cathode. In the middle, you have an iron impermeable membranes, these Teflon membranes. So what did you do? First, you put the brine in, concentrate NaCl in. So this NaCl will react into the anode rod, which anode, look onto the bottom of standard reduction potential, concentrate, chloride, chlorine gas should form. So anode will give you chlorine gas. What happened to the remaining Na? The remaining Na will seep through the membranes. When it seeps through the membranes, and this seeping through is better than the early one, asbestos, because these one are more pure. No chloride can seep through, only Na. So once the Na seeps through, now you're on the second chamber. Second chamber, when you put water, and the second chamber reaction is the cathode. Water react in cathode. What should it produce? Look onto the top standard reduction table. Water at cathode always produce hydrogen gas and OH minus ion in solution. So here, this water you input, it forms into hydrogen gas. And then, once hydrogen gas, what still remain in solution? NaOH. And this NaOH can drain out in the solution, dry it up, become pure NaOH. Student, you will realize the early example and the second and this example, they identical in function. They much identical. What's the difference? The difference is this membranes is different. In many countries, the mercury cell, diaphragm cell been replaced by this membrane cell. As anode cathode compartment, they separated by these iron permeable membranes. And so the NaCl seeps through the anode and water goes to the cathode. And they only allow Na pass through. It does not allow chloride to seep through. So only Na can go through, no chloride or no hydroxide can go through. So this gives you a very good product. Now I'm going to talk about a very old process called mercury process. And this process has been not used for a very long time now. But they give very good product, so we just be briefly mentioned. This mercury process, they use mercury, toxic. They also have chamber. On the chamber, the first chamber, they have the anode. Also on the same chamber, they have the cathode. That's strange. And then they have another chamber called decomposer. Now let's see how it works. At anode, on the green chamber, the anode chamber, the chlorine gas will produce this chloride ion. And on the same chamber, Na positive ion will flow down to the cathode of the same chamber. And here they have the cathode. And here they mix with mercury. And of this chamber cathode, sodium, when you react a cathode with mercury, this mercury, they form into the amalgam mixture. And this amalgam mixture, what's special about mercury? I may tell you. Mercury is very good on dissolve other metal. When mercury very easy to dissolve with other metal and very easily. So in the olden day, those gold digger, they digging for gold, they always carry a bottle of mercury because mercury can help to dissolve the gold from the sand. So to dissolve any gold, you will carry with the mercury. So mercury is very good on dissolving other metal. So now we go back to this picture. When this sodium and mercury mix dissolve in the cathode, they will become soluble. Then they will carry on to the next chamber, the decomposer chamber. This decomposer chamber you add water to it. Once you add water, hydrogen gas will quickly form and sodium hydroxide will also form. The remaining mercury will flow back through the system and reuse. This process have a big disadvantage. This mercury process, the quality, they produce very high quality NaOH and chlorine gas, but totally phase out because have very serious environment problem. Because mercury can leak into the waterway and can vaporize. And this mercury accumulate in the food chain in human can cause very serious symptoms, muscle waste, paralysis, or even death. Student of these three chambers, student will find it quite struggling on memorizing. But you can see if you look onto the standard reduction potential, you only choosing the concentrate. If I ask what's the anode of the concentration sodium chloride, what did you get? Always chlorine gas. So here, what anode will produce, no matter what chamber, always the same formula. Cathode, what cathode produce? Cathode always is the water react form hydrogen gas and OH minus. As you see, water reduce, the water is reduced. And the remaining in the solution is the Na combined with the OH, and on the Na and the OH. So, and how is these two products? The diaphragm process only give 11%. The expensive to operate is an old cell we don't use anymore, cause health problem. Membranes process. Membrane cell, it give much better, so this is what we use. It give up to 30 to 40%. They are more efficient cell. They don't have the mercury or the asbestos problem. So membrane cells is the best. Now we go to the mercury cell. Mercury cell equation a bit more complex. Anode still the same, but cathode, they were using the top formula. Instead of water, they using the sodium, react into pure sodium and mix with mercury. The remaining will be much the same. The yield, they have the highest yield. They give the best quality, but very expensive to operate, and environment problem is the biggest concern, so it's been totally phased out. Student, if you find it very hard to memorize all these steps, I suggest you rather to concentrate onto the standard reduction potential of this concentrate. What will you get on anode? Dilute, what will you get at anode? Concentrate and dilute, what will you get at cathode? So this standard reduction potential that you use will help you and to save you a lot of time, and you will get the correct answer more easy.